The next point is about approximate value of a function. With the help of differentiation, we are going to find the approximate value of a function. So it's like this. For example, you know tan 30 degree. Now with the help of differentiation, you can find like this tan 31 degree, tan 29 degree, and so on. Right? 30 degree you know, but tan 31 degree you don't know. Either you need to use scientific calculator, or here with the help of differentiation you can find it. Between 30 degree and 31 degree, that error is 1 degree. So like this, error should be small. Then you will get the more accurate answer. For example, you know root 20, like you know root 25, but with the help of this you can find root 25.1, root 25.3, and so on. Same way you know how to compute, for example, square root of 49. So you can compute 49.1, 49.5, and so on. So this is what we want to do. We want to get such values with the help of differentiation. So let's recall. This was the definition of derivative. Limit h tends to 0, f of x plus delta x, sorry, I'll write h only here, h minus fx upon h. That was the definition of derivative of function. Now here that h is very small. Fine. Limit tends to 0 means what? It's very small, and that is you know, it is actually like this. So it's a difference of values of variable x. So usually that h is denoted by delta x. That's because that's the error in x. So sometimes here, and we drop this limit also. So we can write like this: f dash x is roughly, approximately, f of x plus delta x minus here fx. This is h, which is delta x. So I can, okay, I'll take, let me write right now right over here. So finally I'll take this as a subject of the expression. So f of x plus delta x, which is roughly this one into delta x, and fx on the other side. So fx plus delta x into f dash x. This is the formula. The derivation is not important for you, just for your information I've shown. You need to use this. If you realize on the left hand side, you see you have x plus delta x. So this is error. This is a function, and here you have error into f dash x. So you need function plus its derivative. So we use this formula. What is the formula? F of x plus delta x, that is roughly equals to fx plus delta x into f dash x. What is this x plus delta x? That is the value you want to get here. Suppose I want to get tan 29, then x plus delta x is 29 degree. Tan is a function. What is this x? So what is x here? That is nearest to x plus delta x, whose value is known to you. So in the above example, suppose I'm doing for this, then for me x plus delta x is 29 degree, this inner value. What is x? You get the value which is close to this, for which tan is defined. So obviously my x is 30 degree. And once you know these two, what is delta x? That's the difference of these two, x plus delta x minus this. So delta x will be here, when you do this minus 1 degree, right? That way will do. And you need function. So what is my function here in the above example? That is 10x in form of variable. And you can write its derivative, which you know f dash x equals to sec squared x. Right? So we use this in almost all questions of 6.4. Single formula, this one, everywhere. Both are same, these or this. Same formula. X plus delta x, that's something you want. This value that is nearest to this, whose standard value is defined. For example, if you are talking about this question, then here x will be 25. What is x plus delta x? That is 25.1. What is your error? This is called error actually. What is your error here? That is, 25.1 minus 25. So 0.1 is your error. And what is your function? If I'm doing this, then my function will be root x. And you can write its derivative. Function will be root x. So here you can write its derivative 1 upon 2 root x. Fine? That's what we want to do in the next exercise. So exercise 6.4. Here in first question we have a number of sub questions. Everywhere we are going to find the approximate value. So the first one there, you are asked root 25.3. You need function here. What is function? Root x, like variable. You write its derivative. What is its derivative? That is 1 upon 2 root x, we know. Okay. Now you just state the formula. You can write x plus delta x f of is roughly, here fx plus delta x into derivative. We have this formula. Now we write the respective values. What is x plus delta x? That is something you want to get, which is 25.3, which is your x plus delta x. What is x? That is the nearest value whose square root is defined, which is obviously 25. So what is delta x? This minus this, which is delta x. So how much? Delta x will be 0.3. Okay. Now we put everything here. So f of 25.3, but f means root. So it will be root of 25.3. Got it? This is how much? 25.3. And function is root. So root of this. This is what you want. What is fx? That is root 25, because here x is 25, which you know. Plus, what is delta x? 0.3 into f dash x means in this derivative, instead of x, you write this 25. So 1 upon 2 root 25. You can call this as just 1, and here this is by 1. That is by above formula. Okay, so this is approximately 5. This is 5, but approximate value of 0.3 into, what is this? 1 upon, this is 5, so 10. So approximately 5 plus, this will be 0.03. So this is roughly 5.03. This is the required value, root of 25.3. Fine. That's the approximate value of how much? Root 25.3, which is we are getting 5.03. So in all sub questions, this is the procedure. Right? You just follow this. The other two questions are about root only. So in the I'll write x plus delta x for your information. 49.5. Function is this only in the second and third. The same function you can use in the second and third sub questions because you are asked root value. Now what is x? Find a number whose square root is defined. That is 49, standard number. Delta x is the difference of these two. This minus this. So delta x will be 0.5. Fine. So you can now do as I did the first one. For the third sub question here, what is x plus delta x for the third sub question? That is something you want to get. What you want to get there in the third sub question? You want to get 0.6. So x plus delta x is 0.6. Fine. Now what is x? You can take here x as a, for example, 1, whose root is defined. And what is delta x? That is this minus this. What is this minus this? It will be minus 0.4. Right? Now you can continue further. Okay. Let's go to next question. Question number, for example, fourth one. You want the approximate value of 0.009 raised to 3. You want this, right, in the fourth sub question. So what is your function here? That's quite obvious. The function will be, I'll write here function variable x raised to 1 by 3. You get its derivative. What is its derivative? that is 1 by 3 will be in the product, x raised to 1 by 3 minus 1. So 1 by 3 into x raised to minus 2 by 3, that is derivative. What is x plus delta x here? That is something you want to get. That is this one. So x plus delta x will be how much? 0.009. What is my x? Number that is close to this whose cube root is possible. So you can take 8 here. Right? The cube root of this one can be obtained very easily. It will be 0.2. That's why we have chosen this. And from this you can write delta x. What is delta x? This minus this. So delta x will be how much? This minus this. It will be 0.001. That is your delta x. Fine. Now let me use the formula here. So I'll use the formula. What's the formula? F of delta x, that is roughly fx plus delta x into f dash x. Now this means required value, that is 0.009 the whole raised to 1 by 3. This means, you know, in the function you put x, so what you will get? 0.008 whole raised to 3, cube root of this. Delta x you did how much? 0.001 into f dash x. In the derivative you put this 1 by 3 into, I'll take that down so it will be positive. What is x? You know here 0.008 raised to 2 by 3. It was minus, but I took in the denominator. Now approximately, you know, this is 0.2 cube root of this. 0.2, 3 times you will get exactly this. 0.001 as it is by 3 as it is. Here first you know, raised to 2 by 3 means first you take the what? Cube root, and then you square it. If you take cube root, it will be 0.2 and then you square it. So what you will get here? 0.04, right? And then here you have 0.2 plus this is 0.001 upon here 12. So you will get how much from this? 0.12. And this much you can simplify with the help of calculator even simply. So what we'll get from this? Or you can do direct simplification also, 0.008. And therefore your final answer is how much? 0.2. We are just adding this to 0.208. That's nothing but the approximate value of cube root of this one. Fine. Now what about next question? In the fifth question here, in the fifth question, what is your function? Your function will be x raised to 1 by 10. Variable x I have chosen. Now you must have realized. So what is f dash x? 1 upon 10 into x raised to minus 9 by 10. Okay, what is x plus delta x? That is given value 0.999. What is your x? Obviously you should choose 1 here because 10th root of 1 gives us 1. And what is delta x from this? That is the, so now same way if I go to 7th question, there fx will be obviously x raised to 1 by 3. You know how to differentiate it as we did in the 4th. Right? Okay, 8th question. There again fx equals to x raised to 1 by 4. So you can differentiate it using x raised to n formula. What is x plus delta x? That is something you want to get, which is 255. What should be my x? You take one value whose 4th root is here, 4th root is defined. So how do you choose there? You just think for a while, how do you choose that value in the 8th question? So it should be how much? Obviously 256, whose 4th root can be defined very easily. So what is your delta x? Delta x will be this minus this, which will be minus 1. Fine. Choosing this is very important. What is the derivative? 1 by 4 into x raised to here minus 3 by 4. Okay. And then use the formula f of x plus delta x, which is approximately fx plus delta x into f dash x. Place all approximate value. This is nothing but how much? Function raised to 1 by 4. So 255 raised to 1 by 4. Fx means here 256 raised to 1 by 4. What is delta x? Minus 1. F dash 1 by 4. This I'll take down here. But x is 1 here. Sorry, x is 256. I'm sorry. So 256 raised to 3 by 4. Now simplify all this. 256 raised to 1 by 4. You can compute very easily. Minus 1 by 4. You take fourth root first, which you are going to find here. Then you take the cube root and simplify. That much you can do. Okay. What about the other questions? All are similar. In 10th again, if I go to 10th, you want square root of 401. So your function will be root x. You know its derivative, that is 1 upon 2 root x. And then you continue. What is x plus delta x? That is something you want to get. What is your x? Take a number close to 401 whose square root is defined, obviously 400. So what is your delta x? This minus this. This minus this. So delta x will be 1. Fine. Okay. So same way I think you can try the remaining questions. I'll directly go to question number 2 now. Second question. Main question 2. It's the same question, their just language is different. Function is already given to you. 4x squared plus 5x plus 2. In earlier questions you were deciding this. You need its derivative. So derivative will be 8x plus 5. Now what is asked? F of 2.01. So you want this f of 2.01. So this is your x plus delta x as per our discussion. Something which you are asked, that is always x plus delta x. What is your x? We can take that as 2 because 2 can be placed here very easily. So what is delta x? This minus this. So delta x will be 0.01. Is it? Okay, now use the formula. Therefore, f of x plus delta x, which is approximately fx plus delta x into f dash x, as we did in all earlier questions. Here, this is 2.01. So f of 2.01, that's what you want. Here 2, f of 2. So put 2 here everywhere. 4 into 4 plus 5 into 2 plus 2. I place 2 everywhere. What is delta x? That is 0.01. F dash 2, but x is 2. So here you put x equals to 2. So 8 into 2 plus 5. Got it? This is nothing but 28 plus 0.01 into what about this? This is nothing but 21 here. So 28 plus here, how much we'll get? This into 21, so we'll get the 0.21. And therefore final approximate value is 28.21, f of 2.01. With the help of differentiation you have computed here. So fourth question now, third is same as second. Find the approximate change in the volume of a cube. So V equals to, side you are given x cube. Okay, so you want change in the volume here. What is given? That is the change in the side. That is dx equals to 1% of x. You are given change, increased side by 1%. So here it would be 1 by 100 of x. So it will be 0.01 into x. This is dx indirectly given to you. This question is just same as the first exercise. Now we want the change in the volume. So dv by dx equals to 3x squared. So change in the volume, that is error in the volume. dv equals to 3x squared into dx. But what is dx? It is this much. So I'll write the 3x squared into 0.01 into x. So we'll have here this into this, which will be 0.03 into x cube. That much change in the volume. Here side you are given x meter, so here I should write meter cube. So in the next question, fifth question, find the approximate change in the surface area of a cube. As we were discussed in the first exercise, surface area is given by 6x squared. You know there are 6 faces and each face is a square. Here x, here x. So area of each face is x square and there are 6, so 6x squared. This is surface area. We did in the first exercise if you remember. Okay. Now what is given here? That side x caused by decreasing the side by 1%. Okay. So your side is x and there is a decrement in this, so we put the minus sign, 1% of x, so it will be minus 0.01 into x, that is dx. The minus sign indicates that there is a decrement. Now from this we just differentiate it with respect to x. dA by dx is equal to 12x, so ds, which is equals to 12x into dx. You can write this step as we are doing in integration. So 12 into x as it is. What is dx? That is minus 0.01 into x. So multiply these two. So minus 0.12 x into x, which is x squared. So again here also this minus sign indicates that there is a decrement in the surface area of the cube with unit meter squared here. Okay. Next question, sixth. It's again like this only. Sixth question, if the radius of a sphere is measured as a 7 meter with this much error. So if I take r as a radius, then radius is measured equals to 7 and error in the radius equals to how much? 0.02. That's error. Find the approximate error in the calculating its volume. So here it talks about the sphere. So volume is 4 by 3 pi r cube. Error we are given, what we want? dV when r is 7. Just same as what you did in the first exercise. So we differentiate this here. So dV equals to 4 by 3 as it is, pi being constant as it is. This is 3r square dr. Now we place the value here. This will get cancelled. 4 pi r. R is 7 here, so 7 square. dr is how much? It will be 0.02 change in the error, which is 0.02 meter. So now question is just simplification. So here it would be 49, 4 into 49 into this is just 2 by 100 into here pi. So here just multiply this and simplify, you will get the 3.92 into pi, this area in the volume, so meter cube. That is your answer. This is just same as what we did earlier in the first exercise. In the seventh question, it's about calculating the surface area of a sphere. So at least that I'll state, surface area of sphere, which you may not be remembering. So I'll write just surface area S is equal to, it's a differentiation of volume 4 pi r square. And now you just, as we did the last question you do as I've discussed there. Just only important one is here, formula for surface area, which is 4 pi r square. What is given here? Here r is 9. If r is 9, you get the change in the surface area, that is indirectly question. And what is error in the surface area? That is 0.03. That's also given, meter. So use this. First you need to differentiate it as I did earlier. ds is equal to 8 pi r dr. So 8 as it is, pi as it is. What is r? That will be here 9. And what is dr? That is 0 point here, how much? It is 0.03, and simplify, and finally it will be meter square. That's your final answer. Now last MCQ, it's like question number 4th only. You have volume of a cube which is Vx cube. Error in this much is given, x cube with the side this much error, which is increased by 3%. So 3% of x, which will be 3 by 100 into x. Right. Now we just differentiate this. So dv equals to 3x square into dx here. So we have now, we are just putting the value 3 as it is, x square as it is. What is dx? That is 3 by 100 into x. So 9 by 100, it would be 0.09 x cube. The unit will be meter cube. dv equals to change in the volume. And that is nothing but the option C.